Okay, so number 1, we're on page 365. So this is really just testing all the given probabilities. Each one says a given. Okay, so we've got a Venn diagram about pets. We've got cats, birds, and dogs. And we're looking for, the first one says, cats given you own a bird. So what should I probably find first of each circle? The total. Take a minute and find the total for the birds, total for the cats, total for the dogs. Because we have to have our totals first. What are we getting for, did anyone get birds yet? 15 sounds great. How about cats? 28 is perfect. And dogs? 19. Okay, so now we've got our total, so we know what we're out of. So if I want cats given birds, who did I have to have first? I'm only looking in the what circle? The birds. So I have a total of 15 birds, and how many cats crept into that bird circle? A little more than 2, I think. 12, because all of these are in the cat circle. So I think we're going to go 12 out of 15. Bird given cats. Bird given cats. Bird given cats. Again, who do I want to be out of? I want to be out of the cats, which we said was 28. So in here, I'm looking for the birds that crept in. How many birds snuck in there? 12 is correct. 12 out of 28. So we'll put 2 minutes on the clock, do C through F. And again, don't go too far ahead. I'm going to skip around a lot today. C through F. Here, what do you think he's doing?
That was going?
Mm-hmm. 5 points.
5 points, Luke.
5 points. All right, Luke. D given in B. What do you got for us? Agree or disagree? Agree. Perfect. 4 out of 15 sounds great. Sarah, what are you thinking for B given in D? 4 out of 19. Agree or disagree? Agree again. I think that's great. Total's 19. 4 birds snuck in. Perfect. Miles, C given in D. You said 8. I'm just 8 over 19, you said? Agree or disagree? Agree again. Perfect. 19 total. 8 snuck in. That's great. And D given in C. Grady, what are you thinking? 8 over 28. Agree or disagree? Beautiful. That's great again. Are we feeling good with these givens? Okay, so the given in is what's in the denominator. Flip the page. We're going to go to the back, so page 366. Let's look at question A. Determine whether the events are being mal and passing are independent or not. So remember, not dependent, just independent or not independent. What is our formula for independence? I've got mal and passing. What's one formula I could use? We'll use M and P, yeah. Probability of M. Do we all agree with that? So we write our given and we choose the first, or, but if you put P first, the probability of P given M would then have to equal probability of P. So it doesn't matter which way you go. Pick one and apply the math. So I'll give you a minute to apply the math. Now you won't get the same fractions, but they're both correct solutions. Grady, were you supposed to be in study hall this morning? Were you supposed to be in study hall this morning? Oh. Felt like I marked you absent, but maybe that wasn't a choice. I better go back and look. Sorry, I just thought of that. Let's see. Vinny, what do you have for M given in P? Agree or disagree? I think it's good. I agree. Males given in passing. So I had to be in passing, so my total should be 120, and the males in there are 66. I agree with that. So those of you that disagreed, can we help talk you through that? Miles, how you doing? You good? I'll do that one next, yeah. And then just probability of male. How many males are there? 110 out of 200. Okay, so because that's not a given, it has to be out of the actual total. And then I just want to see if those are equal. I have my calculator. The odds are they're what? Not equal, but you still need to show it. And now, again, like on the exam, they try to force ones that make it happen, so don't be surprised if you get some. Oh, they are equal, aren't they? Holy smokes. 0.55 equals 0.55. So what can we actually say for the first time, I think? They are independent. They are actually independent. That's awesome. Okay, so if you went the other way, a couple people went the other way, let's just compare their fractions. If they had probability given male, not probability, pass given male, they should be 66 out of what? 110. And then the probability of passing would have been 120 out of 200. So 66 out of 110 is 0.6, and 120 out of 200 is 0.6. I'd have 0.6 equals 0.6, which is still independent. Okay, so either way you went, you should have got the same independent answer, different numbers obviously, but same independent answer. Okay, like I said yesterday, probably a good 60%, 60 to 70% is on independent. Okay, let's see, flip to page 369. 369. All right, so we have patrons at a local sub shop were asked whether they preferred white bread or Italian bread, if those were the only two options. They were also asked to pick their favorite veggie topping amongst tomatoes, banana peppers, olives. Complete the following table. So take a moment, find your missing values. So you have some totals, you should be able to find the missing values. How do those numbers compare to yours? Anybody stuck finding them? Okay. So let's do the same thing. Let's put a few minutes on the clock and start looking for each of these events, and then we'll compare in a few minutes. So 1 through 7. Okay. I want you to circle the two numbers where you had to memorize a formula for. Out of 1 through 7, which two did you need a formula for? 5 5 and 7 are perfect. You needed the OR formula here, and you needed the independent formula here. The rest are just kind of common sense. So the probability white bread, now I think there's 1 or 2 people that earned a 0 here. Somebody literally just wrote, or 2 people I think wrote 575. Can 575 be a probability? No, it has to be less than what? 1. There is 575 people that prefer white bread, but that's out of 1,000. Remember, these answers have to be less than 1. White bread given tomatoes. Steph, what's your setup for white bread given tomatoes? 250 over 460. Agree or disagree? Yep, I think that's great. Bell peppers given Italian. Merrick, bell peppers given Italian.
180 over 425.
He says 180 over 425. Agree or disagree? Good. So we're looking at the Italian and the bell peppers in there. That looks great. Okay, now, I don't have any givens, right? So because it doesn't say given, it's out of the total amount. How many people like olives and Italian? 35, and that's out of everybody, so out of 1,000. This phone is going crazy, Merrick. How do you live like this? My desk is blowing up. All right, tomato or Italian. So now I need the formula. When I see or, it's the probability of the first one plus the probability of the second one, but then I have to take out the part that repeats, the and. So the tomato lovers were a total of 460 out of 1,000, plus the Italian lovers were 425 out of 1,000. But when I added this plus this, I counted what number twice? 210, so I have to take 210 out of 1,000 out. So I'm really just going to add the numerators because it's still out of, they all have 1,000 in common. You know, if it's short answer, they might argue with you on that. If it's multiple choice, nobody knows, right? So I'd be cautious. Like if it's short answer, you're showing off your skill set now. I would make sure I put that on there. The rubrics are very interesting how they read them. So if it specifically says you didn't, then we have to take it off. What's that? I know. Yeah. So again, multiple choice, no one knows. Olives. It looks like we have 170 olive lovers out of the 1,000, right? So if it doesn't say given, we're out of the 1,000. Any questions on the first 6? Okay, independent. I see the word independent. I have one option. I have one formula I have to memorize here. I'm testing for independent. So I could say the probability of white bread given tomatoes equals the probability of which one? White bread. I could say that, or I could say the probability of tomato given white bread equals the probability of tomato. It doesn't matter. You don't have to show both. You have to pick one and get the math right. So let's say I went white bread given tomato. I think we already found that up here, right? White bread given tomato was 250 out of 460. And then just the white bread lovers were the 575. We found that already too, out of 1,000. Were those equal? No, 0.54 and 0.57. Close, but not equal. So I'm going to say they are not independent. Probably not. But we don't know that, but probably not. All right, question 2. Yeah, go for it. Oh, real life.
How do they find probability for like events where one event is like highly more likely than the other, even if there's only 2 choices? For example, I thought of this because of my disasters class, where we were talking about the probability of one asteroid hitting Earth, where it's only 1% chance that it hits the Earth, and there's a much higher chance that it doesn't, even though there's only 2 choices that hit the Earth or it doesn't.
Correct. You want to know what formulas to use for that? I'm going to have to table that and come back to that one, Dree. But I like how you're thinking. Kind of the same with like the March Madness. Like one team has a higher percentage they're likely to win versus the lower seed team. Again, there's no guarantee. But I can talk to you later about that. Number 2, we've got 300 people surveys and asked for 2 questions. Do you own any Nike apparel and do you own any Under Armour apparel? So what do you think we should probably be drawing here since they didn't really give us anything? Definitely a Venn diagram type question. Okay. 185 indicated that they own Nike, 169 indicate that they own Under Armour, 79 said they own neither. So take a minute, put some numbers in there where you think they belong. Can I put the 185 inside of a circle? No, that's just our total circle. How about the Under Armour? 169, and again, just the total. It can't go in there. The 79 is the neither, so that actually goes outside. And the last thing I know is that they asked 300 people. So what am I going to do with these 3 numbers? Add them. So let's go ahead and jot that down so we don't forget. 185 plus 169 plus 79. $433 sound right? Is that what you said? 433. Now you'll notice that number is much bigger, but that means the difference is where they overlapped each other. So all I have to do is take that 433 and subtract 300, and that means they overlapped 100. So 100 people own both Nike and Under Armour. Does that make sense? That difference is the overlapping part. All right, take a few minutes and answer 8 through 13. Oh, did I screw something up? 133. Oh my gosh. Hold on. Yes, 133. What?
I thought we would find the middle, you have to add X. And then, like...
So I think that's when we knew like this side and this side. Then we said this plus X plus this equals that. But we didn't have that those pieces of information, so this one's just a little different. Yep. All right. Which is the only number we needed a formula for? 9. This guy you had to memorize the formula for. The rest should really just be kind of common sense. If I'm in Nike and Under Armour, what number's in both Nike and Under Armour? 133 out of 300, out of the total because it didn't say a given. Okay, now I need my formula. So I need the Nike total. The Nike total is 185 out of 300 plus the Under Armour total, which is 169 out of 300, minus the part that's in both, so minus 133 out of 300. So 185 plus 169 minus 133, I think I get 221 out of 300. So again, that's the only one we needed a formula for here. Okay, so I want to know how many Nikes are in Under Armour. So who should my total be out of? 169, because I'm in Under Armour, and how many Nikes are there? 133. I want to know how many Under Armours are in Nike. So I had to be in Nike, so I should be out of 185. And how many Under Armours are in there? 133. Okay, so again, the rest of these have no formulas. It's just common sense. You're in Nike, but not in Under Armour. What part of the circle's in Nike, but not in Under Armour? Not 185. Alex, what'd you say? Where'd you get 52 from? Yes. So I'm looking for this side. This X here would be in Nike, but not Under Armour. So to get that, we're taking the 185 that are there, and we're taking out the 133. 50, does 52 sound right? Out of how many? Out of the 300, because it didn't say given. Okay, so this one says I want to be in the Under Armour, but not in Nike, but not here. So I want this section. So I want the 169 minus 133 should get me 36 out of the 300. Okay, so I'm out of 300 unless it specifically says a given. All right, that little half, flip it over, backside. Little half sheet you picked up at the door. Take some tape, pass it around. I didn't get any of these questions on here, so I'm just going to put mine sideways. And this is review for these types of questions. So I put some tape coming around, or got some tape coming around, but this little sheet you picked up at the door. This formula is if we assume A and B are independent. Okay? So this is not a test for independence. They're telling you they are independent. That formula said you can take the probability of A and do what with it? Yep, multiply by the probability of B, and that's equal to the probability of A and B. Okay, there are a bunch of these on the test tomorrow as well. This is the independent formula if they tell you they're already independent. Okay, so think and means multiply or means add. All right, given the events A and B are independent, underline that for yourself. You can tape it when it comes around. They're telling you they are independent. I'm going to this formula right away. Okay, it wants A given B. Now, I can't find that right off the bat. Okay, so let's draw what we know. I know the probability of A is 0.94, and I know the probability of B is 0.4. But because they're telling me they're independent, I'm going to jump to the formula for independent. So I'm going to take the probability of A times the probability of B and say that's equal to the probability of A and B. Okay, because they said they're already independent. That's the only reason I'm picking this formula is because they said they're independent. So I'm going to take the probability of A, which is 0.94. Multiply it by the probability of B, which is 0.4. So we need 0.94 times 0.4. I'm getting 0.376. Verify that with me. 0.94 times 0.4. Nope. Oh, okay. Yep, give me 1 second. So let me put my 0.376 in here. Okay. So again, this will get me the and section. And if I want the probability of A given B, I want to know how many A's are in B. So what should my total be out of? 0.4. And how many A's are in that B circle? 0.376 divided by 0.4 should be, yes, 0.94. So yes, Dree, yes, that works right off the bat. You don't. We're just talking through it. We're just saying we can use this formula. Okay. So if you didn't catch to what Dree's saying, the quick way to get that would be if they tell you they're already independent, then we know the probability of A given B should equal who? The probability of A. So if I knew the probability of A, I should know A given B. Now if they said B given A, well, then you know that as well. Number 2, given the events A and B are independent. So again, they're telling you they're independent. So I'm picking this formula versus the other one. Determine A and B. So when I hear and, I'm thinking they're going to do what with those two? multiply. So I've got 0.36 times 0.7. 0.252 sound right? All right, last one. The events A and given the events A and B, A is this, B is this, and A or B is this, determine whether A and B are independent. All right, so again, I'm going to kind of just draw out what I have. I've got A and B. I know A is 0.6, and I know B is 0.5. And I know A or B. So the moment I saw or, I'm going to start with the or formula. So the probability of A, or means add, plus the probability of B, minus the probability of A and B, is equal to the probability of A or B. And we've memorized that formula. Or means add and take out the middle. All right, so I know the probability of A is 0.6. I know the probability of B is 0.5. I don't know the probability of A and B, but I do know the or is 0.8. Could we easily find the probability of A and B? Okay, so use your calculator. If I bring all that junk over, I get a negative 0.3, but I have that equaling to a negative probability of A and B, so if I divide out the negatives, I should get the probability of A and B is equal to 0.3. Does that part make sense? Okay, so where does that go in my picture? The middle, you got it. So now it says determine whether A and B are independent. Now, I don't know they are, so I can't use this formula. I'm now doing the test for independence. I have to test it. So I need the probability of A given B is equal to the probability of A. I have to do the test now because I don't actually know if they're independent. So if I said A's in B, I'd have what number out of what number? 0.3 out of 0.5 sounds great. And then the probability of A is just 0.6. So 0.3 divided by 0.5 gets us 6 twice in one day. So I can now say A and B are independent. So again, I had to use the test formula versus the other one because we don't know they're independent. We're testing it. Does that make sense? All right, so that covers everything on the test tomorrow. Your homework, and you've got time to start now, is the probability finale page. So just this page, I don't know what number this is, 268. It says probability finale at the top. It's just the front side, just this side that I have on the screen, probability finale. Okay. I don't have answers on the page, but I posted them on class.